Hey, I hope the videos so far have been helpful. I was doing the problems a bit randomly so far, but I think it's nice to solve and get good at each topic before moving forward. So the next few videos are going to be focused on arrays. I'm going to try to put up one video every couple of days, so I hope you can follow along, learn with me, and become comfortable with common coding questions and patterns in the next few months. Alright, let's jump into the question for today. Insert delete GetRandom big of 1. You can pause for a minute and read through the question. Basically, we need to implement a class and helper methods which enable insert, remove, and getRandom methods in constant time. From the data structures we know, a hash map comes to mind first. And a hash map allows big of 1 insert and delete. Because the way a hash map works is that we have a certain key which runs through a hashing function, and that gives us the location for where the value is stored. So this gives constant time insertion and removal. Let's quickly write these down in a table so that we can see which data structure can perform which operation. So like we discussed, the advantage of using a hash map is that insertion and removals can be constant time operations. But when it comes to the getRandom function, all the hash map is doing is hashing a key to get the location. So to get a random value from the entire dictionary, with the probability being equal for picking any value, that's not possible using a hash map. When it comes to an array, insertion can be constant time because we are just appending a new element to the end of the list. And getRandom can also be constant time because we can generate a random number within the length of the array, and that can be done in big of 1. Coming to the drawbacks of each, we can't get a random element in big of 1 for a hash map. At the same time, we can't do a removal of a value for an array in constant time, because if the value is anywhere in between, that element would have to be removed, and the rest of the elements in the list would have to be rearranged, which is a linear time operation. So in order to achieve what we're looking for, where we want insert, remove, and getRandom to be big of 1, we can think of using a combination of a hash map and an array. Let's say we use a list and a dictionary, and let's look at this example where we have the following elements in the list. We have 5, 15, 7, 9. It's just a bunch of random elements in the list. And in the dictionary, we can store the keys being the elements themselves, which will be 5. And the value can be the index of that element in the list. So 5 will have a value of 0, 15 will have a value of 1, 7 will have a value of 2, and 9 will be a 3. This combination of using these two data structures can help us achieve constant time operation for these three methods. Let's look at how each of these operations would look. The first operation is insert. If we were to perform an insert, we need to append that to the list and also add it to the dictionary. So let's say we are inserting a value of 3. So we add 3 to the end of the list, and we also update it in the dictionary. So we'll have a key of 3 and a value which will be the index of 4. That would be a constant time operation. Next, we have remove. For remove, it could be any value in the list. So let's say we wanted to remove 7. There are a couple of steps we need to do here. It's easy to remove the last element in the list in constant time. So what we do is swap 7 with 3. So in that case, 3 would come here and 7 would become the last element. And because we did this, we also need to update the dictionary accordingly. So update so the value of 3 in the dictionary would be the new index, which is position 2. We can now get rid of 7, so we do a pop on the list, which would remove 7, and at the same time we could delete the entry 7 from the dictionary. See that we did a couple of steps here, but all of them are constant time, and the new list and dictionary that we have do not have 7, and 3 is updated to a new position, and that position is also updated in the dictionary. So this entire set of operations was done in constant time again. The final operation we're looking for is GetRandom. So for GetRandom, we can pick any element in the list, but it needs to be of equal probability of getting picked. So we can just pick a random index and use one of the libraries in Python to get a random element. And this can also be done in constant time. So based on these operations, the combination of using a list and dictionary enables us to do all of these in big O of 1. We're using the advantage of the list being able to pick a random element and the big O of 1 lookup and removal in a dictionary. Based on the example we just discussed, let's write some pseudocode to see how this can be implemented. So the methods we have, first we'll have an init where we can initialize a list and a dictionary. Then we have insert. We can just return false if the value is already present. If not, we can append to list and update dictionary. Then we have the remove operation, which has a sequence of steps. We return false if the value to be removed is not present. Then we need to place the last element in the position of the value to be removed. Then we update dictionary accordingly. And then finally, we can delete the value both from the dictionary and the list. Our final operation is GetRandom. This should be fairly straightforward and a number of ways to do this. We could use a random method and pass the list to fetch a random value from the list. Implement the solution. We have an init constructor where we can just initialize our data structures. And we also need a dictionary. They'll both be empty. For our insert operation, the first check we need to do is if the value is already there in the dictionary. In that case, we just return false. If not, we can append the value to the list and update that index to the dictionary, which keeps track of all the values and the corresponding indices in the list. Since we're appending it to the end, we can just do length of self.list -1 and we return true. For remove, there's a sequence of steps to be done. So we first check if value not in dictionary, we can return false. If not, we need to move the last element to the position of the value which we want to remove. So let's first fetch the index of the value which needs to be removed, which is stored in the dictionary. Let's also get the last element, which will be self.list -1. -1 can be used in Python to refer to the last element. If not, if it's some other programming language, you might have to use length of the list -1 as the index. Now that we have both of these, let's update our list and dictionary such that the last element occupies the value that we want to remove. So to update the list, we can do self.list of val index to be equal to the last element. We also update our dictionary accordingly. So self.dict of last element would be the index. Now that we've updated both these values for the last element, we can remove the value from both these data structures. From the list, we can just do pop, since now it's at the last index, and we can delete the key from the dictionary. And we return true. For doing the GetRandom, since we have them in the list, there's a number of ways to do it. Let's just use the random library. Let's import that. You can just return random.choice and pass in the list. This will just pick any element from the list. Let's go ahead and run this code to see if it works for the given example. Looks like it does. Let's now submit the solution to check for all possible inputs. Yes, that works. So looking at it, this problem feels fairly straightforward, but it's quite tricky if you think about it. And we had to intelligently use a combination of a list and a dictionary, or an array and a hash map, to achieve the solution. Hope this helped. Thank you.